The next part will be the preparation of organic compounds. There are 4 compounds are given. One is a acetylated aniline. This is called commonly acetanilide. This is called acetanilide. This is the first compound. How you prepare this compound means take aniline. Its preparation involves the taking the aniline, add acetylated aniline. So, it is called acetanilide, or from this side it is ethanoic acid with ammonia, ethanamide with phenyl. N-phenyl ethanamide is also the IUPAC name. In fact, acetanilide is a common name. So, acetylation can be aniline, you take, add acetic anhydride. Or you can take acetyl chloride directly. Thereby, the acid group can be introduced into the aniline. Take aniline and add the acetic anhydride or acetyl chloride, acetanilide is formed. The formed compound will have some extra group. What is that? This acid group will be there, that is all. Acetylated aniline is acetanilide. This is the first compound. Very simple experiment. Take aniline in a round bottom flask, add this one by adding itself. If it is anhydride is very pure, it becomes hot actually, but boil for some time for around 30 minutes and then cool it, add excess of water, then acetanilide comes as a white crystalline compound, filter it and submit. The second preparation is a paranitroacetanilide. Paranitroacetanilide. Means you have a nitro group at para position. The above upper group is same. Acetylated aniline plus paranitro. Now, the problem in this compound theoretically, aniline on nitration, there is some problem. One is a nitric acid is oxidizing, amino is a strong activating group, therefore, the oxidation takes place. Second one, strongly activated, so many nitro groups may enter, that is the third problem, second problem. Another problem is actually with nitric acid is strong acid, therefore, protonation takes place. When once it is protonated, amino group is no more activating, the nitration becomes tough and it goes to the meta position, because NH3 plus is no more orthopara directing, it is a deactivating and meta directing. Therefore, metanitro compound will come. So, to avoid all this, first aniline you take, prepare acetanilide by acetic anhydride, okay, CH3CO taken twice O, that is acetic anhydride. So, acetanilide you prepare first, that is the above compound NHCOCH3. Now, the acetanilide has got 2 plus points. One is it is a big group, therefore, ortho positions are covered due to the steric hindrance. Nitro cannot be entered at ortho, that is the one point. Another one is the lone pair is partially withdrawn by the CO group, therefore, activation will be low level. So, therefore, slowly activation takes place. No more protonation, the N is no more basic now, it is acidic in because it is conjugated with CO. So, nitration with the ordinary nitric acid, nitration can be done at para. So, paranitro acetanilide can be prepared. If you are interested to have a paranitro aniline deacetylated, H3O plus will give the paranitro aniline also. That is the one method of preparing, in fact, how to prepare aniline with paranitro, means acetylation, nitration, deacetylation will give the paranitro aniline. But our experiment is up to this one, it's okay, paranitro. But don't nitrate it initially, first acetylate it, then nitrate it, that is the correct procedure. So, aniline yellow, this is the third compound. This is a diazonium salt formed from the aniline and the diazonium chloride. Its preparation is, first you take the aniline, add the NaNO2 and HCl. At 0 to 5 degrees centigrade, cool it and then add. So, NH2 will become into N2Cl. This reaction is called diazotization, diazonium chloride. This is called benzene diazonium chloride. The reaction, one nitrogen being converted into 2 nitrogen, therefore, it is called diazotization. So, through diazotization convert aniline into benzene diazonium chloride using the actually HNO2 will be the reagent which is used, but it is not immediately available. So, its salt and acid is taken, which generates this end lone pair will attack here and then undergoes a small conversion and finally comes out as a N2Cl. That compound you take and then add it to the aniline, but take aniline, dissolve in dilute HCl. HCl is an acid, so it is soluble. So, the aniline is dissolved in the dilute HCl, then add it to this diazonium chloride is added. So, aniline is converted diazonium chloride, again another aniline is taken, dissolve in HCl, then add this diazonium chloride. The reaction is called diazo coupling. A coupling reaction takes place and then you are getting this aniline yellow. NH2 will be there, N double bond N with the benzene. You can write benzene ring or the 3 separate double bonds. This compound is known as aniline yellow. It will have a reddish yellow color and it has got some commercial applications and all that. Where from it is prepared? Aniline is diazotized, then added to the again aniline in dilute HCl. This coupled product is known as aniline yellow. This is called aniline yellow. Last compound, that is iodoform CHI3, which is a painkiller, an aesthetic type of quality containing painkiller, and it is prepared from all the compounds which have got a carbonyl function attached to CH3 or a hydroxy function containing CH3. This side you can have different options. You can have hydrogen, you can have an alkyl group, or you can have an aromatic group. That is one option, acetaldehyde. If H is there, acetaldehyde. If R is there, acetone, 2-butanone, 2-pentanone and so on. If an aromatic is there, acetophenone. Even alcohols containing the hydrogen or alkyl or aromatic also can give this reaction. 2,2-hydroxy or methyl containing compounds, when you treat it with iodine in presence of a base like NaOH, so it will become theoretical. Otherwise, let us take sodium hydroxide and iodine. You too may write OI minus, iodate. In presence of this one, first this CH3 get iodinated. Okay. So, the CH3 will become into Ci3. All the alpha hydrogens or enolizable hydrogens will get iodinated and subsequently undergoes a hydrolysis. This part will become into CHI3. CHI3 is a yellow color and it is a precipitate. Therefore, the moment you get this one, it gets precipitated, filter it and wash with the NF, the base and the water followed by, then you will get this the iodoform, the solid. Even this one also, when you add iodine and NaOH, first it becomes into this type of carbonyl compound. In basic medium, it gets oxidized, the hydrogen and the hydrogen get removed, halogenated into 2 moles of Hi is come out. This compound first becomes into a carbonyl, then iodinated, then becomes into cut into this one. This side you will get corresponding acid salt will be detached. So, this CH3 group is going to convert into iodoform. It is a commercial method of preparation of iodoform from acetophenone or from the acetone. You can prepare a iodoform. This is the what one of the another organic compound suggested. This separation of next topic will be the separation of binary mixture. The 2 compounds, when it is in the form of mixture, binary means 2 compounds. When 2 compounds are mixed, that mixture is called binary mixture. However, with one functional group containing binary mixtures can be easily separable. Apart from the regular separations like distillation, crystallization and all that, we have a specific separation here, solvent extraction. Solvent extraction. In this method, an example one neutral compound like benzophenone. This is a neutral compound, right? Neutral compound. But another compound is aniline. This is the mixture. This is basic. One neutral, one base. These 2 compound mixture, if it is given, what you have to do is first you add the ether, diethyl ether, that is ethyl O ethyl. This is called a diethyl ether, solvent ether. Both dissolves in the ether because both are organic. A solution comes, right? This solution you take into a flask. Just like it will be on the top, it looks like a flask, but when you come down, it looks like a funnel type. So, it is called separating funnel. You can have a facility of closing with the lid, and an operating system will be there just like a burette. So, this both you take in this one solution, which is dissolved in the ether, and a neutral compound and base both are there in this with ether. Then you add some solvent, which is only the aniline enters into that. So, you add that to this plus dilute HCl you add and then mix thoroughly. Add dilute HCl and extract it. Then the ether floats and comes, now here comes the HCl solution. Here comes the ether solution. Now, out of the 2 compounds, only base will come into the HCl solution. A base is soluble in the acid. Therefore, when you add acid, only aniline comes into this one. In the ether, a neutral compound will be there in the ether. So, separate manually, open this here. Up to both are colorless, but differentiating layer will be there. Up to this layer, you collect one side you collect the HCl and base. The other side you collect the ether plus a neutral compound. Evaporate the ether, N comes. Just evaporate it, heat it, ether goes out and N comes. Here, how to get rid of the HCl means you add the NF quantity of the NaOH. HCl NaOH reacts and forms NaCl and water. Now, the base aniline is neither soluble in NaCl or water. So, therefore, base will become separate layer. So, get that base separately. This is not soluble in water, it floats or sinks. So, separately according to the physical nature, you separate this base. So, base and the neutral compound can be extracted with a suitable solvent called HCl. Now, the direct question is, what is the separating solvent when a mixture of neutral and base is there. Okay. Base is extracted with acid, therefore, dilute HCl is the separating solid. This is the first example. Now, let us go to the second example. In a neutral and acid, if it is. Acid means a benzoic acid, let us take. Okay. Neutral means the same benzophenone we take, diphenyl ketone or benzophenone you take. Now, what will be the first? You have to add the ether, okay, ETO, double taken ether. Then you add the one which is extracted, that is KOH. Take the KOH and extract it. Benzoic acid goes into the KOH. So, after that you extract into COH. So, one KOH with the acid will come here. This is acid, isn't it? So, acid will come into here. In the other side, ether plus a neutral comes. Evaporate ether, neutral comes. This you add dilute HCl, then you will get this, the KOH is neutralized. So, the acid compound will come out, isn't it? So, KOH is neutralized with the acid. In the acid, this benzoic acid is not soluble, therefore, acid will precipitate. Like this, different types of the mixtures, one acid and one base may be taken. One acid and the base may be taken. Then what may be the separating mixture means? First you have to dissolve in ether. Both get dissolved. Then either you can add acid or base. If acid is added, that is HCl is added, base is extracted. If sodium hydroxide is added, A is extracted. Now, what is the separating salt means? You can go for the first ether, then second time either KOH or you can use dilute HCl. Either one can be used, the option is there, because acid and base are there. One, if it is neutral, the solvent is fixed, but both you have an option, either one can be used and extracted. Okay. And another type is if a phenol and a benzoic acid is there, both are acids only, acid with a weak, both are acids, that is A with W, let us say. This is also acid, but it is a strong acid. So, what will be the separating medium means? First you add the ether, then you add the second one is the one which get resolved, means bicarbonate you take. If you take sodium hydroxide, what happens? Both goes into that sodium hydroxide, that is not correct. If you take bicarbonate, only the acid goes, but the phenol is not soluble. So, therefore, now after adding bicarbonate and separate into two mixtures, ether will contain the phenol. In the bicarbonate layer, the benzoic acid will come. So, that is acid with strong will come into this one, acid neutral, that is weak base, weak acid will come into the ether left over, and strong acid is extracted by the bicarbonate, because bicarbonate, though it is weak, our acid is strong, therefore, it is get dissolved and comes here. So, therefore, phenol and the benzoic acid both are acids, but because one is weak, one is strong. So, sodium bicarbonate if I use, phenol is not soluble in the bicarbonate, but benzoic acid is soluble, therefore, benzoic acid comes into the bicarbonate, whereas phenol left over in the ether. So, even 3-4 compounds if it is there also, one can go for the separation, but the only thing is one after the one, not at a time. Okay. Like for example, one neutral, one base, one acid is there. Dissolve all three in ether, extract with sodium hydroxide. With sodium hydroxide, that is benzoic acid will come. Base and the neutral will be left over in the. Later you extract that base you extract with dilute HCl. One after the one it can be extracted, and finally all the compounds can be separated. The solubility chart, if you are really aware of this one can implement the separating the medium you have to use. The question also, what may be the separating medium if a neutral and base if it is there, like these two compound, what is separating medium is dilute HCl you have to say, because this is soluble in the HCl, this is not soluble, it is soluble. So, choose one solvent, dissolve in suitable solvent first of all, that is very important. Directly also you can add, but both are one sometimes one is solid, therefore solubility will be the problem. First you dissolve in this one, insoluble one remove it, both are soluble perfectly. After that only apply this solvent extraction, and that is called the separation using this the solvent extraction method.